Hello students, welcome to my YouTube channel, A Binary of Civil. In this video, I am going to solve the assignment number 1 of Soil Mechanics or Geotechnical Engineering. Are you ready? Okay, let's start. So the first question is, the loess is formed by the action of, the option A is water, B wind, C glacier and D is gravitational force. First of all, we need to know there are different types of soil deposits based upon the transportation agency. Okay, so I am writing here. First one is alluvial soil or alluvial deposit. This alluvial deposit is transported by water. There are three different types of water. The first is water from the river, water from the lakes, water from the oceans. So coming to alluvial soil or alluvial deposit, it is transported by running water. Where is the running water is available? Generally in river water. Okay, so the transporting agency is, here it is river water. Here I am writing it is transporting agency. Okay, and it is a type of soil. And if the water is lake water, so then type of soil formed will be lacustrine deposit. If the transportation agency is sea water, sea or ocean, okay, then the deposit formed is marine soil. Okay, if the transportation agency is wind, then it is called aeolian soil. Okay, and if the transportation agency is ice, then it is glacier soil. If the transportation agency is by the action of gravitational force, so then the deposit is colluvial soil. So now coming to the given question is, loess is formed by, so loess is formed by the action of wind. Okay, so it is a form of aeolian soil, it is loess. So from 4 options the answer is B. Okay, clear. So river water, it is alluvial, lacustrine, it is from the lakes, marine soil, it is sea water or ocean water, and aeolian means the transportation agency is wind. So the example for aeolian soil is loess. So that is a given question. And by the action of ice, it is a glacier, and by the action of gravitational force, it is colluvial soil. And the example for colluvial soil is talus. Talus is one example. Clear? Next question. Sand particles are made of, options are rock minerals, option B kaolinite, option C illite, and the last option is montmorillonite. So if you observe all these options B, C, D, these are all minerals of clay. Okay, so clay minerals, what are they? Kaolinite and illite and montmorillonite. So the only option is rock mineral, that is the answer for sand particles. So sand particles are made of, it is a rock minerals. Okay, and next question is, the process necessary for the formation of igneous rock is, so there is a rock mineral, rock metal inside the earth. For example, here it is a ground surface. There is a lot of rock mineral Okay, this rock mineral which is present inside the earth is called magma. Okay, depending upon the temperature and pressure which has been subjected to magma, it will reaches earth surface. Okay, whenever it reaches the earth surface, this we call it is called lava. Okay, whenever the magma reaches earth surface, we call it is lava. This lava, first of all, it gets cooled and solidifies and forms a rock called igneous rock. Okay, so what is the process to form igneous rocks? It is solidifies. It is solidification. So the answer will be option C for the question number 3. Clear? Here the names magma and lava. So you might be able to confuse what is magma, what is lava. So if the rock metal which is present inside the earth, we call it as a magma. If it is present above the earth, we call it is lava. Okay. So coming to next question. A sampler with a volume of 45 centimeter cube is filled with a soil sample. When the soil is poured into a graduated cylinder, it displaces 25 centimeter cube of water. So the porosity of the soil is. Okay. So he has asked, what is the value of porosity? First of all, what is the porosity? So I am writing here porosity. The symbol for porosity N is equal to volume of voids divided by volume of total soil. So I am writing here volume of total soil. Okay, so he has given the sampler volume. The sampler volume is 45 centimeter cube. So that sampler volume is the total volume of the soil. Total volume of the soil V is equal to 45 centimeter cube. And he has given the statement like the soil particles are dropping into the water. So then what we want, as we drop the soil in water, the solid particles will displaces water. So hence the volume of solids will become volume of solids will become 25 centimeter cube. So we know the volume of solids as well as total volume of sample. Now we can able to calculate volume of voids. Total volume V is equal to volume of voids plus volume of solids. From this equation, volume of voids is equal to total volume minus volume of solids. What is total volume? It is 45 centimeter cube and volume of solids is equal to 25 centimeter cube. Then volume of voids will become 20 centimeter cube. Clear? Then porosity N is equal to volume of voids divided by total volume of soil. What is volume of voids? It is 20 and total volume of soil will be 45. 20 divided by 45 you will get it is 0.44. Clear? So this will be the answer, porosity. So what is the option from the given options? So it is 0.44, option B for the question number 4. Is it clear? So here you need to remember the statement, as we drop the soil in water, the solid particles will replaces or displaces water. So in that case, volume of solids will become how much water which is moving from the sampler to the outside, the same amount of volume will become the volume of solid particles. Okay, so this concept you need to remember. Okay, and the next question is the void ratio and specific gravity of a sample of clay are. So he has given void ratio E is equal to 0.73 and specific gravity G is equal to 2.7. If 80% of the voids are saturated, that is, he has given degree of saturation as 80%. Degree of saturation he has given S is equal to 80%, that I am taking it is 0.8. We know degree of saturation S is equal to volume of water divided by volume of voids, and air content AC is equal to, AC means it is air content, is equal to volume of air divided by volume of voids. From the above two expressions, AC plus S is equal to, what is AC? Volume of air divided by volume of voids plus volume of water divided by volume of voids. So volume of air plus volume of voids, sorry, volume of air plus volume of water will be volume of voids, and the denominator volume of voids, that is equal to 1. AC plus S is equal to 1. We know the value of S. We can able to calculate AC is equal to 1 minus S, that is equal to 1 minus 0.8, that is AC is equal to 0.2. Is it clear? So I am explaining this question again from the starting. The void ratio and the specific gravity of a sample of clay are 0.73 and 2.7 respectively. If 80% of the voids are saturated, the air content in the percentage of the soil is, and he has given one assumption, assume unit volume of soil, that is total volume of soil that we need to take it is 1. Okay, so here he has given E is equal to 0.73, G is equal to 2.7, degree of saturation S is equal to 0.8. So we know value of S is equal to volume of voids divided by volume of water divided by volume of voids, and air content is equal to volume of air divided by volume of voids. So whenever we get added AC plus S, so AC plus S we will get it is 1. You will get AC is equal to 1 minus S, that is 1 minus 0.8, AC is equal to 1. Okay, and you can calculate porosity N is equal to E by 1 plus E. We have this relation, that is 0.73 divided by 1 plus 0.73. So you will get it is 0.422. Clear? And we have one relation, percentage air voids N suffix A is equal to AC into N. What is AC? 0.2. N is equal to 0.422. You will get it is 0.084. If it has been converted into percentages, you will get it is into 100, it will be 8.4%. So from the given option, the answer will be option B. So there are 8.4 percentage of air voids in the total sample of a soil. So here you need to observe 2 points. Air content means here we got it is the value is 0.2, that is out of total voids 20% of the voids are filled with air, remaining 80% of the voids are filled with water. That's why air content is 20% and water content is 80%, in which in total volume of voids, but in total volume of soil air content is only 8.4%. Is it clear? Okay, next question. A soil sample has following properties, that is specific gravity, he has given the data, specific gravity G suffix S is equal to 2.7 and void ratio is equal to 0.6 and water content is equal to 14%, that is 0.14, and unit weight of water gamma W is equal to 9.81 kilonewton per meter cube. So now what he has asked, the bulk unit weight, in which units? Kilonewton per meter cube of the sample is. We have a direct relation to calculate bulk unit weight. So gamma bulk is equal to G plus ES into gamma W divided by 1 plus E. In this expression, we don't have the value of S. Okay. To calculate the value of S, we have one relation. ES is equal to WG, that is product of void ratio into degree of saturation is equal to the product of specific gravity and the water content. From this expression, S is equal to WG divided by E. Clear? Or else you can write in place of ES as WG. You can see here, in place of ES I am writing WG. So then this expression will become G plus WG into gamma W divided by 1 plus E. So in this expression we know each and every term. I am going to substitute the value of G as 2.7 plus 0.14 into 2.7 and gamma W he has given it is 9.81. So whenever he has not given the value and if you are not allowed to take the calculator along with you, you can assume sometimes it has a 7, sorry, it is sometimes it has a 10, okay, it is very near to 10. So it is 1 plus E is equal to, it is 0.6. So you can get the value as 18.87 kilonewton per meter cube. So okay, so the option C will become the answer. Okay, so the bulk unit weight of the given sample is 18.87 kilonewton per meter cube. And coming to the next question, so it's one of the most important one. A sieve analysis of a sample has given following results: D10. D10 means it is effective size of the sample for the given sample. D10 means percentage finer, 90% finer. Okay. So he has given D10 is equal to 0.63 and D30 is equal to 2.40 and D60 is equal to 4.57. All the units are in mm he has given. Okay. The classification of the soil based on the result is, okay, he has asked what type of the soil is. It is SM means silty sand. Silt symbol is M and sand symbol is S. Gravel symbol is G, and here he has attached for the sum of the options with P. P means poorly graded and W means well graded. Okay. So based on these letters he has given the options. So to classify by using these different sizes, we need to calculate two values: Cu, coefficient of uniformity, that is equal to D60 divided by D10. So he has given all the values, D60, D10 values. You can get 7.54. Cc, coefficient of curvature, D30 square divided by D60 into D10. If you will substitute the corresponding values, you will get it is 2.0. And now coming to which type of soil the given sample will belong. So I am writing here, for well graded sand. So if the soil has to classified as well graded sand, then Cu should be greater than 6 and Cc lies between 1 to 3, right? So its value is greater than 6 because we got the value as 7.54 and Cc lies between 1 and 3, right? So we got the Cc value as 2. So the given sample is well graded sand, that is SW. W means well graded, S means sand. It is well graded sand. Is there any option SW? No, it is not there. But for well graded gravel, Cu is greater than 4 and Cc lies between 1 and 3. So by our calculations, Cu is, we got 7.54, it is greater than 4, right? Is it clear? Even it is greater than 6, but the option is not there, but here it is given 4. Okay, so 7.54 is greater than 4 and Cc values lies between 1 and 3. It is, we can say it is GW. It is well graded gravel. GW, is there any option is there? Yes, it is. So the given soil is well graded gravel. So the answer will be D. Clear? Next question. Here he has given the table. The result of a liquid limit test on a sample are given below. So he has given number of blows and the water content corresponding to number of blows. So 48, 38, 29, 20, 14 and 32.1, 35.8, 40.7. So he has given some table, and along with this table he also given liquid limit. So liquid limit is how much? 43%. Plastic limit is how much? 23%. So from these two values I can calculate plasticity index, that is IP is equal to liquid limit minus plastic limit, that is 43 minus 23. So its value is 20%. Okay. What he has asked, toughness index, that is IT is equal to IP divided by IF. IP we already know, we need to calculate IF. IF means flow index, that is IF is equal to, we have one standard formula, that is from the table, W2 minus W1 divided by log N1 divided by N2. It is base 10. Okay, the logarithmic with respect to base 10. So here it is, W2 is water content corresponding to last value and W1 is water content corresponding to first value, and this value will be N1, this value will be N2. So what is W2? 52.8 minus 32.1 divided by log N1 by, N1 is 48 and N2 is 14. So you will get this value as 38.68. Clear? So, and then toughness index IT is equal to, IP is 20% and IF is 38.68. This will be is equal to, you will get 0.52. Clear? So the toughness value is equal to 0.52. So from the options B is correct. Okay. Next question. So it is a direct question. This type of questions will be asked for 1 mark in the GATE exam. Okay. He has given the liquid limit of a soil is 45% and plastic limit of soil is 33%, and the soil is, so just given liquid limit 45% and plastic limit 33%. So from this expression we can get plasticity index, right? How much? Liquid limit minus plastic limit, that is 45 minus 33 is 12%. Okay. Now depending upon IP values, we have one table, standard table. Depending upon the IP value, what is the consistency of the given soil? So if IP value is equal to 0, the soil is said to be non-plastic. If the IP value is less than 7, the soil is low plastic. If the IP value lies from 7 to 17, it is medium plastic. If the IP value greater than 17, it is highly plastic. Clear? Is it okay? So now what is the IP value that we have got? In which range it will fall? It is fall from 7 to 17. It is medium plastic. The answer will be option C. Clear? And now the last question for the assignment. A fine grained soil has liquid limit 60% and plastic limit 20%. According to IS classification, the soil is, okay, Indian standard classification defines the given soil is come under which category. So to calculate the type of soil, to classify the type of soil, we need to have one chart. So that chart is, it is drawn, liquid limit on x axis and plasticity index on y axis. This is plasticity index and this is liquid limit. So here there is one line, we call it is A line. What is the equation for this A line? IP is equal to 0.73 liquid limit minus 20. It will pass at a liquid limit 20. Okay. And now to classify the given soil, whether it is low compressible or medium compressible or highly compressible, depending upon the given liquid limit. So there is one line here at 50, there is one line here at 35. Okay. So if liquid limit is less than 35, it is low compressible soil. So you will get symbol L, means low compressible. If liquid limit lies between 35 to 50, it is intermediate compressible. So you will get intermediate means I. If liquid limit is greater than 50, it is highly compressible. You will get symbol H. And if you observe the liquid limit value that he has given is 60%, the given soil is highly compressible, means in the given options is there any H? Yes, H is there, that is on the option B, it is CH. CH means highly compressible clay. We have confirmed as of now the soil is highly compressible. So there should be letter on H in the options. And now whether we need to confirm it is clay itself. To confirm the soil as clay, we need to calculate the value of IP of the given soil and IP of the A line. So I am calculating IP of A line. IP of A line is equal to 0.73 and liquid limit is 60 minus 20. You will get IP of A line is equal to 29.2 and IP of soil is equal to 60 minus 20. You will get it is 40. IP of soil is greater than IP of soil is greater than IP of A line. Okay, so that is it will fall somewhere here. Okay, if it is above A line, we call it is clay. If it is below A line, we call it is silt. I am writing here with some other thing. So this entire portion is clay portion. This entire portion is silt portion. Okay, and our soil, the given sample here is, it will fall somewhere here. Okay, this is clay and as the liquid limit is greater than 50, it is highly compressible. So clay means C, highly compressible means H. So the answer will be B. Clear? So listen carefully. If you have any doubts, post your comments in the comment section. I will clarify your doubts. Okay, this is end of the assignment. Thank you.